A function rule is an equation that describes a function. You can think of a function rule as an input-output machine. The x values are the set of input values. That's what goes into the machine. And the set of y values are the set of output values. And that's what comes out of the machine once you put in the x values, or the input. So if you know the input values, you can use a function rule to find the output values. So here they've given us the input values, and they want us to find the output values. They've given us this function, y equals 3x plus 4, and we're going to plug in each of the input values into this equation to find out what the output is. So if I plug in negative 3, y equals 3 times negative 3 plus 4. So 3 times negative 3 is negative 9 plus 4, which is negative 5. So y would be negative 5. When you put negative 3 into the machine, plug it in for x, you're going to get negative 5 as your output. And then we're going to do the same thing. Y equals 3 times negative 2 plus 4. So 3 times negative 2 would be negative 6 plus 4, which is negative 2. So when I put in negative 2, I'm going to come out with negative 2 as well. Then we try again with negative 1. Y equals 3 times negative 1 plus 4. So negative 3 plus 4 is going to be positive 1. And if you plug in each of the rest of these, you're going to get 4, 7, 10, and 13. An equation can also be written with y as f of x. That's the function notation. So y equals negative 2x plus 1 can be rewritten as f of x equals negative 2x plus 1. This is known as function notation. So remember that f of x is just a name. It is not a multiplication thing. It is just the function of x. We know that x is going to be the input value. So they want us to evaluate f of x equals negative 2x plus 1 for the domain, which remember the domain is the x values. Negative 2 is less than or equal to x, which is less than or equal to 2. That means all x values that we plug in must be between negative 2 and 2, including those two numbers. So I can fill in the input or domain or x values on the chart. So these are all numbers between negative 2 and 2. Plug these in to this function to find out what the output is. So if I plug in negative 2, f of negative 2 equals negative 2 times negative 2 plus 1. So negative 2 times negative 2 is positive 4 plus 1 equals 5. So that means when I plug in the input negative 2 into this function, f of negative 2 equals 5. I'll do the same thing with negative 1. f of negative 1 equals negative 2 times negative 1 plus 1. Negative 2 times negative 1 is positive 2 plus 1, that's going to be 3. So the function, when I plug in negative 1, gives me positive 3. And if we continue this table, if you plug in the rest of these numbers, you will find that you get 1, negative 1, and negative 3. So it says an interesting things happen when we graph the input-output pairs on the graph. So we're going to use the table that we just did, and we're going to graph these points. So first we're going to write these points in. These are the same points from the table. And then we're going to go ahead and plot these points on the graph. So remember, to plot a point, we start at 0, 0, you do the x value first, which tells you to go left or right, and then you do the y value, which tells you to go up or down. So start at 0, 0, go to the left 2, go up 5. Start at 0, 0, go to the right 1, and down 1. So go ahead and plot these points on your paper. What do you notice about these points? Well, if you look, they all make a straight line. What do you think would happen if we chose more x values, so we put more numbers in the domain and evaluated it with the same function rule? It would all still fall on the line. So for this reason, we connect all these points with a line that has arrows on the end. So we can connect these points in a straight line and put the arrows on the end. So go ahead and pause the video now and do the understanding check. For the understanding check, notice that it gives you the domain that all x values should be between -2 and 2. So for both of these tables, your x values should be the same, -2, -1, 0, 1, and 2. And then you plug those values into each of the function rules. So here we're plugging into 2x minus 1, and for part B you are plugging into -x plus 2. Be careful with your signs, especially in part B when you have this -x. If you are plugging in -2, that would be -2 plus 2. Because you bring down this negative sign, and this is the negative that was originally attached to the x. So -2 ends up being +2, because it's like multiplying a -1 times -2. And then you add 2, so that is how they get 4 here. And then we graph these points on our graphs, and notice again that it makes straight lines that we are going to connect with a line and arrows on each end. We are going to skip this page for today, so now you are going to go on to your homework. Your homework is just the same as the understanding check you just did, except notice that the domain changed, and they want you to now use the values between -3 and 3. So for each table, you should have the values from -3 to +3 in the x values, just like you have here. Plug these values into your function rule and then graph the ordered pairs on the table.